The project I have taken is like the loan default prediction. So it's a machine learning approach to have a like financial risk assessment. So the project objective is below. Like the problem statement was, as of now, the financial institution like face significant challenge in identifying borrowers at a high risk of defaulting on their loans. So this project like leverages machine learning to predict loan defaults, enabling proactive interventions and reducing financial loss. So the key stakeholders are like the banks and the financial institution, the credit risk managers, the risk underwriters, and the government lending programs. So yeah. So what I have taken as a approach for the data preparation is as the data set was were presented the Kaggle, so which has around like 2,55,000 of rows and 18 columns were there. So and there were no missing values like ensuring the data quality. And the out of these 18 columns, like the key features include loan amount, the credit score, the income, employment history, demographic, the marital status, and all. After that, I have done a baseline model training. So established like a logistic regression model, and I have splitted the data into like 70% of training, 30% of testing data sets. And after that, I applied like standard scalar for feature normalization to ensure like consistent model performance across all algorithms. Yeah. And after that, I also use like different models in this data set, like KNN and decision tree, random forest, and all. Yeah. So coming back to the data sets, so like what is the feature importance? I have plotted one chart, so which says like age has a highest contributing feature and all, and there are some categorical values like the loan purpose, loan term, and the education, marital status. So for those things, I have used the one hot encoding for and converted them into like columns. Uh, yeah, so the class distribution, like the final result, whether it is a default or not. So the we have a like imbalanced data sets which has a non-default of like 88% of the data was having no default, while the 11% of the data was having a defaulters. So yeah, so after that, like what I have used as a like data processing pipeline. So first I have used like check the data quality, so no null values were present. After that, I've done some exploratory data analysis which includes uh, how is the different parameters are behaving, and like I have plotted different bar distribution plots for defaults versus non-defaults across age distribution, credit score, violin plots, and like categorical variable analysis across education. So these are some EDA process that has been done in the project. So after that, like feature engineering, which includes categorical data sets, converting categorical data sets into the one node encoding, and then training and testing of the data sets, and feature scaling so that uh, the features are normalized and all. And after running the like different models, I have used like logistic regression, random forest, LD in a discriminate naive KNN and decision tree. So logistic regression has a like based the overall like random forest was having the highest accuracy of 88.53%, while the logistic regression and LDA was able to give the excellent ability to distinguish between default and non-default cases. Since ROC was higher for this uh, model. So I have one like the detailed analysis of the logistic regression performance. I plotted the confusion matrix for the data sets, which shows like the true negatives were 67K, true positives were 307, false negative 189, and false positive 189, false negative 8617, and the precision for defaults was like 62% when predicting default, and recall for this logistic regression was 3%, uh, which which is catching 3% of the actual defaults basically. And similarly, like I plotted the ROC curve for this logic. Mm, I guess this is for
So
logistic
3%
regression
was
only.
the 3% was the recall.
Uh, yes, recalls for
That's
defaults.
very. Oh, I think there is a strong data imbalance in your case.
There was like 88% was 88% was non-defaulter, and around 11.6% was defaulter.
Oh, that's why. That's why. That's why. Okay. Did you do the stratified sampling and other things to overcome that part?
Uh, Statistical sampling.
Stratified sampling. Stratified sampling. I think that's why your recall and precision are so skewed. You
Oh,
got
I
to.
haven't
What?
used that smart and more.
Okay. Okay. No, you have to just do a equal batch from both sides and train the model on equal batch from both sides.
Okay, so
So yeah.
this is the like reference and the data source link, and this
Okay.
is the insights. Because of
Okay.
class imbalance, not the recall is high and all. So that's
Okay.
it.
Okay. Okay. Alright. All right. Yeah. Work on handling the imbalance because imbalance in the data is more real than you may think. Okay. It's a real problem in every project. Okay. So as a work for yourself, I think work on handling the imbalance on this. Okay.
Sure.
Yeah.
All right. Thank you, Sumit. Next is
Good work. Good work. Thank you.